Okay, let's finish up these notes for this 310. Oh, this one is so good. This one makes me happy. So they ask you, basically they give it to you in standard form in the graph, which it looks nice. Look, there's the y-intercept of 2. It's counting by 2s. The graph is a little hard to tell that it's a y-intercept of 2. It's an x cubed, so it's a snake baby. It's just nice. And then they tell us to factor. You don't know how to factor this, guys. And you can tell if you look for roots here, they tell you -2 is a root, but these two are in-betweeners. So how are you supposed to tell what those are? And this happens a lot in polynomials. So what we're going to do is we're going to write what we know. If -2 is a root, because we can see that one nicely, and if you type this into your calculator on the table, it would show up nicely, then go ahead and write that factor out. But we just need to figure out what would be left here. And it's probably going to leave me something that's not factorable because these two guys are probably square roots. They're in-betweeners. So what you're going to do is you're going to put the -2 in a box, and we're just going to divide it out and see what you have left, and we're going to use synthetic division. So 1, -2, -7 into, and then we drop the 1 and we have our party. We multiply, we add, we multiply, we add, we multiply, we add, and you should get a remainder of 0. If you don't get a remainder of 0, then that wasn't a root, and they told us it was a root, so you know you're right. So that means that x squared minus 4x plus 1 times x plus 2 is this guy. And this is actually completely factored because while there are, I could factor this over the, like if I find all the x-intercepts and zeros, this cannot factor further. I can do my end behavior. As x goes to -infinity, it's going down to -infinity. And as x goes to +infinity, y is also going up to +infinity. I could do the domain as well. The domain is -infinity to +infinity and -infinity to +infinity. But I need the rest of the roots because there are 2 other roots. So those last 2 roots come from this guy. You can do quadratic formula, which is not going to be hard here, or you could complete the square, which is what I'm going to do because this is a nice even number. That's an x minus 2 squared, which would leave me 4 in the corner, but I have to get to 1. So I will subtract 3 to get 0, and then we'll just solve it. Add 3, x minus 2 squared equals 3. Square root both sides. Don't forget your plus or minus. X minus 2 is plus or minus square root of 3. And there are those last 2 roots. 2 plus square root of 3 and 2 minus the square root of 3. If you wanted to write these two as factored form, you could have. I did not. It would look like this. X minus 2 times x minus parenthesis 2 plus root 3. X minus parenthesis 2 minus square root of 3. And you could have distributed that negative as well. But I didn't do that. Okay. So that one was tougher. And the last one. Okay, function and factor form. This one I think I can factor. It is a cubic, so it's going to be a little snake baby. I could do end behavior first if I wanted to. But there's a GCF here. So they have an x in common, and that leaves me with an x squared minus 2. That is factored completely. So one of the roots is 0. What are the other 2 roots? The other 2 roots come from solving this. X squared minus 2, if that equals 0, you would just add 2, and you get x squared equals 2, square root both sides. Plus and minus the square root of 2 are the last 2 roots. End behavior before I graph if I want, that's fine. As x goes down, y is going down. As x goes to the left, y is going down. And as x goes to the right, y is going up. The domain will be -infinity to +infinity. And the range will also be -infinity to +infinity. When I graph this one, some of you were asking about even and odd functions. This one actually is an odd function. There was an even function earlier. The question that had the W was an even function. I don't think we saw any other ones. Everything else was a neither. Yeah, there was 2 W's. The one we graphed. So what do we have here? Number 2 was even. And number 5 was even, if you're looking at your notes. Everything else has been neither, and this is our first odd one. So if you graph it, where's my cursor? X cubed minus 2x Oh, punch somebody in the face. But nobody's here, so everyone is safe. Don't worry about it. X to the cube minus 2x. Okay, grapher. Ooh, I'm on the Zoom still, but isn't that pretty? Zoom 6. Okay, so there it is. You'll want to know what those 2 points are. So second, calculate. Let's do maximum. Yeah, so it's like negative 0.81. So when you graph it, keep that in mind. And the other has symmetry, and it will just be the flip-flop if you did second calculate min. So what I have here, I want it 0 and like negative 0.8, like 1.1, so it's up a little bit higher. And then this one ended up being like 0.8, negative, like this, kind of. The square root of 2's when it hits in there, it comes back down. Kind of like that. Mine wasn't very good, but that's good enough. Okay, so that's it for the notes on 310. Then you'll look at 310 Ready, Set, Go next week. And then I'll give you a little review video for your test to make sure you have everything you need. And we'll be done with Module 3. And then after that, I'm going to give you a little optional study guide for the final. We'll talk about that plan next week. Oh, it did record the whole time.